presentation.
Outline.
Screen not visible, sir, please.
Outline.
Not yet.
Huh?
Not yet.
Visible,
Not
sir.
yet.
It
The
is not
screen not visible, sir.
Oh, visible, sir.
It's visible now. Visible.
Outline.
visible.
Yes, sir. Outline.
Is it
Yes,
visible?
sir.
Yes, 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 sir.
Are you observing the first slide outline?
Yes, sir.
Yes, sir. Visible, sir.
Yes, yes.
Visible, sir.
So outline of a present will be concept electronics, difference in traditional conventional approach and electronics approach, and their IoT and mechatronics to and mechatronics and references that we use. Faculty at the end of the session will be able to understand concept of mechatronics, understand the key features of mechatronic systems.
Hello, sir. Voice is not clear.
Conventional.
Sir, please check it.
Is it not visible?
Audible, sir.
If it is visible or not?
Yes, sir. It is visible.
So basically,
No, sir. Yes, sir. Now it is presentation is visible.
So, it is taking a little bit time to load on the participant screen. So I appeal all, please have patience, and sir should start the continuing the presentation. Okay, it will load. Have a little bit time.
Because Microsoft Meet or Microsoft Meet this particular online meeting software. We tested it previously. It was working fine, but I don't know what is exactly happening during this particular time. So should we now which slide you are observing on your screen? Outline,
Yes, yes.
Outline.
Third slide is visible now.
Okay.
You are on the third slide. Go to the second slide. So on the second slide,
At the
go
end
by
of
arrow.
this, the end of
Continue.
we will be able to understand concept, then understand key features of mechatronic systems, understand conventional oblique traditional approach of mechatronic system, understand IoT with mechatronics. Then in machine learning and implement towards understanding concept of industry 4.0 and with mechatronics. So I think is it visible?
Yes, sir. Yes, sir.
Yes, sir. Visible, sir.
Correct the audio problem.
Carry on, sir.
Brief.
Carry on your.
So first of all, I will like to tell you mechatronics is the term which is coined by engineer Etsura Mori in 1969 at Yasakawa Electric Company, Japan. Up to 1980, mechatronics is meant only for the combination of electronics and mechanical engineering. After some years, after new inventions, computing technology added with development of computers. What is mechatronics? Mechatronics is the synergetic combination of mechanical, electronics, microprocessors, and control engineering. It is concurrent engineering. It applies rethinking of machine component design by use of mechanics, electronics, and computation. It allows more reconfigurability. It is having optimal combination of appropriate technologies, and it gives the emphasis on integrated design of products. In bird eye view, we can say mechatronics is electronics, mechanical, software, control, system design. Examples which includes modern automobiles, spacecrafts, marine vessels, robots, factory automated systems, etc. If you observe this diagram, you will observe over here that mechatronics is at the center, and other disciplines, that means let us say control systems may be digital, it may be electronics control, so digital control system and electronics control system, which will be integrated with the mechatronics. For electronic systems, again we can say control, electronics, electromechanics, it is a part of mechatronic system. For mechanical systems and uh, mechanical CAD, electromechanics, all these are the mechanical compositions which are getting involved as an integration part to the mechatronic systems. Again, for computer, what we can say, basically you are designing mechanical simulations or mechanical softwares using computers. That's why computer is the inherent part of your mechatronic systems. And computer can be used in mechanical applications for mechanical CAD design, as well as with the digital control systems, which is getting implemented using computer. So computer, control, electronics, mechanical, these all disciplines are playing important role in mechatronics design. Am I audible?
Audible, sir, but the
Yes, sir.
sir,
Yes,
you're audible, sir, but your slide is not moving, sir.
audible.
It is getting slow. Matlab, this slide is not front of you right now.
History slide is there, sir, right now, and it's going on. Audible, you are audible also.
Please start the slideshow.
No, I started already slideshow.
Everything is fine, sir.
Someone is saying
Screen is not getting
everything is fine.
enlarged.
Huh? No, no, presentation.
It should be full screen.
हाँ फुल स्क्रीनच आहे ना ते.
No.
दिसत नाही का तुम्हाला?
हाँ नहीं है.
Slideshow, please.
Click on the slideshow.
Slideshow.
स्क्रीन 1 ला जाऊ का मी परत? स्क्रीन 1 ला जाऊ का?
आता
Or should I send you PPT? You will start from your place. Huh?
स्लाइड नाही आता. काहीच नाही स्क्रीनवर तुमचा फक्त हे इमेज.
So should I send you my PPT?
हाँ.
You can start from your place.
Okay.
No, there should not be any problem now. Sir. नितीन पाटील सर.
हा येस सर.
मी तुम्हाला पीपीटी सेंड करतो.
हा मी माझ्या स्क्रीनवरून प्ले करतो. तुम्ही फक्त तुमच्या स्क्रीनवरती ती दिसेल. तुम्ही मला नेक्स्ट म्हटलात की मी नेक्स्ट स्लाइडला जाईल.
ओके फाईन. तुम्हाला मेल पाठवली बघा मी.
एकच मिनिट सर लॉग इनच होते.
Wait, Nitin.
Yes sir, just a minute.
Just just a minute. It will get loaded, I think. Is it visible now?
Yes, sir.
Is it visible?
Yes sir.
It is visible,
It's
but not
visible.
full screen.
Key features of mechatronic systems. Uh, as we have seen that the mechatronics is the combination of various disciplines. As I have shown over here, we can correlate this example with our human uh, development. Every engineering is applied. It is available in human day-to-day life. Human being itself is example of mechatronic systems. We are having integrated parts like brain, eyes, then we are having nose, tongue, ears, heart, hands, legs, every component of body, they are connected together. And we can't separate out from their integration. Because of some reasons, suppose hand, leg get fractured, we are replacing it by artificial operations, or we can say by surgery, by operations. But it is not possible to replace with the original quality of that particular part of the human body. Means, what I want to say is that you can't replace human part with artificial part. Though your technology is getting developed day to day, but still, though it is called a replacement, but still it will not give the same quality as a natural, uh, you can say, the quality of performance or quality of that part which is given by our God or nature. But in mechatronics, as we said, mechatronics can do anything. Mechatronics is having large range of applications which can be which cannot be discussed. So distinctive characteristics of mechatronic system is the tight coupling between different technological fields. For example, mechanics, hydraulics, electromechanics, pneumatics, electronics, computing, and software. The microcontroller is an essential element in mechatronic systems, and software content is currently developed very rapidly. Mechatronics plays an ever more important role for different business sectors such as in industrial products, consumer goods, and automotive systems. Additionally, the importance of mechatronics is today also reflected in higher education, where it has become a degree on its own, being offered in many tertiary education institutions. Right now in Sinhagad Group, there is one course of mechatronics in mechanical disciplines, specialized in mechatronics, ME mechatronics. And our university is also trying to introduce it as a separate course in our academic curriculum as a separate course. So you can understand from this what is the importance of this subject in our daily life. Suppose there are four engineers, let us say mechanical, electronics, electrical, computer. Suppose I am asking some questions on mechanical topic, like maybe gear, maybe CAD cab, maybe CNC, like that. Electronics people or computer people may not able to give the answers as per the requirement or as per the from solution point of view. If you have if the mechanical engineers is asking the questions about the all microcontrollers, microprocessors, or different intelligent operations which can be based on you can say directly on uh, various components, then mechanical people may not give the answer. It is like that. But mechatronics engineer must give the answers of all questions which which can be related with that particular product. Try to understand. Mechatronics is a product. It is end application. It is a device. It is a product. While IoT, machine learning, whatever recent trends that we are discussing, all these are nothing but the tools, technologies which are available. Mechatronics at the end, it is a technology, but it is integrated. Mechatronics development end with the product. Likewise, suppose we are having uh, let us say scanner. Scanner is a part of mechatronics. Computer, laptop, smartphones, all these are the examples of mechatronic systems. That means, hello, hello.
Sir,
Hello, sir.
continue करा.
Yes, sir.
Yes,
Sir,
sir.
Am I
Audible,
audible?
sir. Audible.
Yes, yes, sir.
Slide systems are there. Slide is there. Slide is available. Slide is there.
Sir,
everything is
gone.
perfect, sir.
Fine. If anything is there, you please inform me. Otherwise, I will be finding that I am going and then there is some issues like that. It should not happen. And my dear participants, I am requesting you all, as we are doing all these efforts to interact, to give some knowledge to our students, to our faculty, there may be some hurdles, but we will definitely overcome it so that we will focus on our end gain that we are going to get. I am sure that by patience listening, by cope up with the system, all of you will be getting benefited. So with this, I will again go with my presentation. So mechatronics is having information systems. It consists of system modeling, system analysis, system design, system techniques. All these are information contents, information systems consisting of all this part. Then mechanical systems. Mechanical system is getting information or mechanical system or motion, what we can say, is getting sensed by the sensors, then it is given as input to the electrical systems, then ADC, then it is interfaced with the computer and it will be displayed on the end, you can say display board that is shown in this particular place, this block diagram which is shown over here. And computer system, it is interfaced with the controller and control system. All these are given as input to all components which are shown uh, for the mechatronic systems. All this controller is the brain. In mechatronic system, now as we can separate out like this, end element, end target of mechatronic system is motion, which is mechanical component. You can drive gears, you can drive some you can say motors which will cause the displacement. End element is mechanical component and processing is done in CPU, which is definitely electronic component, preferably electronics component, and transmissions which are showing or transmissions which are done or communications which are done, it is of computer and processing algorithms, coding, all this part will be taken place by using computer algorithms. So we can't separate out any component from other component. They are integrated towards each other. That means, as I told you, suppose I am removing leg from body because of some reason, there is some surgery takes place, and you can have an artificial limb which can be corrected. Though it is shown that science is going ahead and artificial limb plays role, but it will never replace the natural limb that you are having, which is given by the nature, as I told you. And as the integration, as I told you, Integration is nothing but it is total compact design. Total compact. Integration means what? Summation in our mathematical way. It is that means you are integrating all information from some time to some time. That is the definition of integration. In mathematics, we are calling it as a area under the curve. But what is meant by integration in mechatronics? Isn't it? Integration means they are combined together as a compact device, and this compact device is like our module. That's why uh, mechatronics is a product which can be supported by IoT, machine learning, all these things you are doing with the interfacing part of microcontroller or microprocessor or computer, or we are having some programming codes which are written in the computer. So this part we have to understand and whatever discussion we are doing. So we will go ahead with this. So what is difference between conventional approach and mechatronics approach? Many of our students as well as faculty they are not able to give perfect answer. I observed it. I interacted with many students. I observed that they are observing mechatronics. Yes, we understood. But when I ask them the basic understanding, the basic difference between conventional approach and mechatronics approach, they are not able to give me the correct answer. So let us go to this part because it is we have to understand conventional systems are bulky while mechatronic systems are very compact. Mechatronic systems are conventional systems are bulky and we are having large systems we are connected with wires cables which are connected large bulky systems now which are getting replaced by mechatronics technique by small compact devices. It is first difference. Conventional designs have got complex mechanisms while mechatronics based systems have simple mechanism. Now let us say our mobile phone. In our mobile, all part which is covering the electronics part
Sir,
is
please
designed.
change the slide. Slide is remaining there.
Right. I have changed the slide. I have changed the slide. After changing
Slide is
only,
not changed. On our screen, the slide is remaining same. First slide itself.
Bird's eye view.
bird's eye view.
So I view
Bird's eye
that
view
screen is
mechatronics.
remaining.
I think sir there is some issue with something. Internet is there is no issue now. Light come back, and I am on that particular uh, slide place, but I am not able to run the presentation. That means though I am running it, it is not getting
No, sir.
reflected over there.
सर हॅलो सर
Uh,
हा आता बरोबर आहे तिथं क्लिक करून ॲरो कीनं पुढे जात जा ॲरो कीनं पुढे जात जा म्हणजे दिसत जाईल किंवा त्या पर्टिक्युलर स्लाइड वरती क्लिक करत जा माऊसने
is it now visible difference in conventional?
येस 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 इट इज
Okay, fine.
क्लिक
Fine,
करत
please
जा
tell me.
तुम्ही त्या स्लाइड वरती क्लिक करत जा म्हणजे ते पुढे जाईल ऑटोमॅटिकली
नाही मी करत असतो तेच करतो नेहमी ना आपण आता पण तिकडे दिसत का रे हे मला कळत नाहीये.
नाही अपडेट व्हायला वेळ लागते. हा.
Fine. We will go ahead with whatever things are there. We have patience, having patience because uh, these things are not in our hand now. Because okay, fine. Now conventional design have complex mechanisms, while mechatronics based design have got simple mechanisms. Now, parts or components in conventional systems are connected to cables with mechatronic systems, have bus or wireless based communications, and we are exempted from problems which are caused by bulky cables. So, these things are getting clear like parts of components in conventional systems are connected through cables, while mechatronic systems are having bus structure or wireless based communications and we are exempted from the problems which are caused by bulky cable. In conventional design systems, components are connected, while in mechatronic systems, they have got autonomous units. Now, suppose I want to let us say example of our mobile camera. We are having mobile camera, which is a separate part. Audio is there, then camera is there, then all functions are there on the mobile, isn't it? As I told you, mechatronics is an example of mobile is an example of mechatronics system. Now, body of the mobile is of mechanical design, but mechatronics engineer is aware about body of design as is having knowledge of mechanical also. Electronics is having PCBs, DSP processors, then buses which are connected, camera which is connected, input, output, displays, everything is connected in mobile. Suppose for example your camera gets broken, then you are going to shopkeeper. You are telling that my mobile camera is not working, and he will be saying that, sir, how much days how many days before you took this mobile? Let us say you told that it is 2 years back. He will tell you that, sir, please replace mobile because camera repairing is not possible. Isn't it? Sometimes it happens. Sometimes, not sometimes, many times it happens. It is why, because camera is integrated with that particular mobile. In suppose you are connecting camera as a separate unit in our conventional uh, approach, isn't it? Then you may face the problem of integrity. You may face the problem of specification, size, everything. Now in mobile, your battery is inbuilt. Now it is not possible easily to remove the battery or to replace the battery from the modular device. You have to replace mobile only, isn't it? Let us say in case of laptop, you are having motherboard, batteries, they are embedded. It is also integration, isn't it? But they are connected with compatibility inside. Now you can't compare the example of laptop with mobile directly because mobile is a more compact device than laptop. In laptop you can replace battery. You can replace battery with the specifications which is designed and size dimensions and hours of battery and the slots of battery. Similarly, it happens with RAM. RAM is having slots, motherboard having slots, versions, RAM having versions. All these should be compatible. So design is done in mechatronics approach in such a way that they are integrated. Here you can replace in case of your laptop camera because size of laptop is somewhat more than that of mobile, so replacement is possible. Here also replacement is possible, but that is not that easy because as they are integrated. Suppose I want to replace my hand, it is not that easy to replace. You can replace it, but it is not that easy to replace with the quality that you desire as a natural uh, God given bit by the nature, isn't it? So conventional systems are mainly, so this is what I want to say with the conventional design and integrated design. Conventional designs are mainly operated with the feed forward control and linear analog control, while mechatronic systems are operated through programmable feedback and with digital control in 99% time. Precision in control, precision in conventional systems can be brought through narrow tolerances, while in mechatronic systems, the measurements and feedback control are used to bring tolerances in the system. The qualities, now in conventional systems, what happens? In conventional systems, non-measurable parameter. Now let us say we are having a conventional system. Let us say I am driving a vehicle. Okay, I am a human being. I am driving a vehicle, four-wheeler, and I am going with some speed. Let us say 80 kilometer per hour. Now I am changing some track, and I am observing that road conditions are not good. Then what I will do? I will apply brake. I will change the speed, directions to avoid the obstacles in the path. That means as a human being, I am going to observe the road conditions. That is the intelligence which is available with human brain. Now in mechatronic systems, we can provide artificial intelligence, artificial brain to the system. That means the automatic guided vehicle will change the directions, will avoid the obstacle, will change the speed, We'll try to change the gears if required. Accordingly, this artificial intelligence will be incorporated in the mechatronic systems by using maybe machine learning algorithms, neural network based training algorithms. So intelligence is provided by using machine learning approach in mechatronics. That means that means uh, that means these mechatronics systems can be used to provide the uh,
Excuse me,
intelligence.
sir.
हाँ बोला.
Sir, a slide, there is no movement, sir.
There is no movement.
Yeah. It is the only difference in conventional approach and mechatronics design approach.
Now visible. Next slide. Fifth point, number 5. Oh, same slide is there.
There.
Same slide is there, sir.
Sir,
you go to
that what I see what is happening. Basically, I am telling you, I am going getting the issue. I think this is not the problem of now from my side as well as for internet point of view. I think there is some problem with the things that are available. I will not put my direct words over there because when I am using some other these things tools, I am not facing such problems because I am regularly taking lectures on PPTs using different apps basically, but this is not getting that much effectively that I am observing right now. I have to go back again. Now you will be observing the slide. I have to go back. Then again I have to start with the current slide. Now you will be observing conventional systems are mainly operated, isn't it?
Yes, sir.
Because I have stopped I go back to my PPT presentation. Again I started my presentation. That means current PPT. Getting it? This is what is happening right now. Now suppose I am going ahead, you will not get the next slide. You are not getting next slide now, no? You are having same slide that I showed previously.
Yes, sir. Same slide is visible.
Same
Same slide is visible.
slide.
That means it is not a problem from your side as well as from my side or as well as from internet side. I think this is the problem of some of that means this is to be improved as far as our Microsoft team. Yeah, Microsoft team issue. We have to improve it. We have to give feedback to them to improve this. Now I should not use this sentence during this presentation, but repeatedly I have to go to the previous slide and I have to start with the current slide. Then I will get that slide. Getting it?
Okay.
Yes.
That is what I observed because I had done it 5-6 times and then I come to the conclusion. Previously I was thinking there is some mistake by internet speed, maybe from my side, maybe from your side, but it is not like that. Now I have power, I have internet connection properly, there is no issue, so it should be.
Last session it was correct, no problem.
Huh?
In the morning session there was no problem. Slide show.
So what I will do, you do one thing, sir. You start from your side. You start from your side. I will stop my presentation. I will stop my presentation.
Patil sir, हे करा तुम्ही.
Because we have to take
Presentation
properly. Otherwise, I will not find comfortable if I am not able to deliver due to some issue.
सर स्लाइड चेंज होत आहेत का स्क्रीनवर?
येस होत आहेत कंटिन्यू. हां होत आहेत सर. पाटील सर स्लाइड चेंज होत आहेत, कंटिन्यू करा तुम्ही.
तुमच्याकडनं करा, मग तुमच्याकडनं करा. स्लाइड शो मध्येच करा तुम्ही. स्लाइड शो मध्ये जा.
हां चेंज होत आहेत सर.
स्लाइड शो मध्ये जा
आणि फुल स्क्रीन करा सर.
Now I am not observing it. Now when you are delivering from that place, I am not able to see PowerPoint presentation here.
सर तुम्हाला नाही दिसत आहेत काही अंगल सर?
नाही ना, मला आता दिसत नाही रे.
तुमच्या स्क्रीनवरती 2 काय स्क्रीन आलेत का बघायची. त्यात एक स्लाइड्स असेल, दुसरी तुमचा व्हिडिओ असेल असं काय झालंय का बघा.
आले आले हो, आले आले आले.
हा 2 स्क्रीन असतील तुमच्या समोर, त्यातली स्लाइडच्या ह्याच्यावरती क्लिक करा आणि दिसेल मग तुम्हाला प्रेझेंटेशन.
स्लाइडची आता मला दिसते,
हा हा
पण ते पॉवर पॉईंट फॉर्मॅट मध्ये दिसत नाही. म्हणजे F5 दाबल्यावर जे करतो आपण तसं दिसत नाही.
ओके.
हा म्हणजे F5 करून आपण जे बघतो ना प्रेझेंटेशन तसं दिसत नाही मला.
मोठे निलेश पाटील सर स्लाइड शो करा ना, मोठं होत नाही का स्लाइड शो
मोठं
करा.
मी करतो. बरं आता तुम्हाला दिसते का फुल साईन?
फुल स्क्रीन दिसत नाही मला आता.
नाहीये दिसत.
नाही नाही दिसत सर, अजून ते स्मॉल.
ठीक आहे असं कंटिन्यू करा सर.
ठीक आहे, ओके ठीक आहे.
हे पॉइंट नंबर 5 पासून आहे. हा
पॉईंट नंबर 5 दिसतच नाही मला आता. तुमच्याकडे पॉईंट नंबर 8 आलेलं दिसतो. ठीक आहे, आलं आलं. हा असू दे, असू दे, मी असं सांगितलं.
ओके.
So conventional systems are mainly operated. Hello.
हा बोला सर, आवाज येतो.
As I told you, quantities that are non-measurable in conventional systems change arbitrarily, while in mechatronic system we have full control of non-measurable quantities which are often estimated, because we are providing intelligence. Because of neural network you are training the networks, and you are able to find out the solution with the available issue that is you can say available during your applications. Next, point number 8. Conventional systems have rigid construction and changes cannot be made easily, while mechatronic systems we have got elastic constructions and damping that can be introduced by electronic feedback. Conventional systems have got simple monitoring systems, while mechatronic systems have got supervised systems with fault diagnosis systems which are installed on it. Conventional systems have got fixed abilities, while mechatronic systems have the learning abilities to learn from mistakes and environment. Next. Now this is block diagram which is shown over here, integrated approach and conventional approach. Now if you are able to see here, the mechatronics in conventional systems, mechanical and electrical subsystems are, system design is given for the mechanical and electrical subsystems. There is some communication between electrical input given to the mechanical systems, and for and electrical system is connected to load, and source system is connected to mechanical systems. This is what is conventional approach, where your system design consideration is given as input to mechanical systems and electrical systems separately. While in integrated approach, we are having system design which is compact, which is given as a one block to the integrated mechatronic design approach, which consists of mechanical subsystems and electrical subsystems. Electrical subsystems and mechanical subsystems, they are having bidirectional communication. Even you can get the input from mechanical and you can give the output from mechanical to electrical systems. And source system is connected with the mechanical systems, and load system is connected with the electrical systems. But system design is combined together is given. That means system design is integrated approach for mechanical, electrical, source systems and load systems, which is not happening with the conventional sequential approach. I think what I want to say is getting conveyed. System design approach in both integrated and conventional system design approach is different as shown in the block diagram. Next. Now let us understand that we are having mechanical systems, electrical systems, source and load, which are integrated, which is shown in the integrated design approach. Here it is shown that need of identification. When we are designing mechatronic system, we are having, first of all, we have to identify the need and objectives of the system that you want to design. Then we can redefine the engineering specifications. We have to write down all specifications of the product that you want to design. So it is a quantitative and measurable parameters that you are designing. That means size, shape, speed, torque, voltage, current, machine learning algorithms, or smart systems that you want to implement. Everything should be designed on paper. Then we can separate out the design into different parts like operating system, control systems, information systems, electronic systems, mechanical systems, and electrical systems. That means your designing specifications are divided, classified into 6 parts. Operating system, control system, information system, electronic systems, mechanical systems, electrical systems. These are the different 6 domains under which you divide the specifications. Now, next step is what? Next step is we have to integrate control systems with operating systems, control system with information systems. So control system and information systems will be developing a information and software processing systems. Again, operating system will design the interface. Likewise, for electronic design, we are having electronic design process, mechanical systems and electrical systems. We have designed the process because these are the physical hardware issues. Electronics, mechanical and electrical, these are hardware oriented issues and specifications that we can deliver. So that's why they are combined over here. Electronic design process and process design, these are the hardware part. Electronic design and process design. So hardware integration. Now see, on left hand side we are having software integration, and on right hand side we are having hardware integration process. Now hardware and software are integrated using software and hardware integration process. Now once you design this process, your prototype will be ready. Isn't it? We can design the prototype design, will be ready, and we can have testing process after that. Whatever integration part of software and hardware you design, we have to test it first, and after testing, then manufacturing process of that device will be taken care under all possible conditions of environment, or maybe under all different conditions under which this testing will be carried out, and then the manufacturing unit or manufacturing of that product will start, and the final mechatronic system will be deployed in the market using final mechatronic system product. Next, this is how the integration works. Hope this integration part and conventional part you may be able to understand. Now mechatronics, there are different applications. Now see, all these trends are latest trends. If you are observing mobile, if you are observing CNC machines, if you are observing robotics, IoT, Industry 4.0, everything is now getting smart. Why to make smart? Right from drilling machine, car, gearing mechanism, cameras, everything is getting automated in compact way with the integration point of view. Now only maintenance is taken place by card replacement basis. Now in mobile camera also, if it is possible to take out the camera from that embedded, you can replace it, but it is not that easy as I told you. Human hand, human leg, human body part can be replaced. But what is the conditions? Now let us say one 70 years old person want to replace its limb or hand. Doctor is asking, they are not recommending to replace this old man. Why? Because his resistive power is less. His quality of acceptance, sustainability, is less, and he will suggest that don't go to surgery. He is old, his immunity power, resistive power is less, and though we can do the surgery on his leg or hand, but we will not recommend to replace it because it will create more problem because he is having issues of maybe diabetes, asthma, maybe maybe high BP, low BP. So we will not recommend to replace because conditions of that body of that particular person is not supporting for the operations. Likewise, suppose you want to replace camera in mobile, technically you can replace it, but that is not that easy. Your mobile should be adaptable for that new change. Otherwise, if your mobile is of having low grade, then replacement of camera will cause the problem with some other sections of that particular PCB, and it may create more problem. And that's why it is based on system. What I want to say. Next. Now, as I told you, scanner. We are using different scanners in our office, in our day-to-day life. Now, there are some example of these are. Now, you will see that why these scanners and all this part you are calling as a recent trend. Now, you compare the technology which is developed because in other sessions of our workshop, they are going to work on machine learning, IoT, Industry 4.0, robotics, automation, every part they are going to cover, and all these are recent trends. All these are emerging trends. That's why, suppose I want to cover all the topics in my presentation, it will be creating more and more complications. Why? Because because to discuss about robotics in 2 hours, it is not easy job. We have to first of all understand what is robot and how it basically works. What are different components? What are the concept of degree of freedom? How to calculate payload? Now, suppose I am starting with the robotics and automation, I have to discuss with the application, and at that time we may not touch to our basic concepts. That is what I want to convey, that we will go to the basic concepts first, whatever terminologies which are important to understand as a emerging trend of mechatronics, we have to understand that concept first. Once you understand the concept, how it is working with its basic operation, then definitely that particular recent applications development in that particular product or application, you may be able to understand very fastly. All these FDPs and workshops, we are trying to take it in this COVID situation so that the faculty and students should get benefit of new technology. It is also application of mechatronics because we have to interface. But all these systems as a systems of communication is integrated. Whatever I am delivering from this side, at the same time you are going to receive it in ideal conditions. Sometimes it may create the issues because of the parameter that we are not going to, that we are not considered, or the platform that may be used. They are not getting trained with that particular disturbances. All these things are related. What I want to convey. Every engineering starts with our human body, human growth. You will observe that it is integrated approach. Why? You will observe that suppose 5 years boy, take example, 5 years boy having all dimensions, having 2 legs, 2 eyes, 2 legs, 2 eyes, and 2 ears, 2 hands, everything is there. But you will observe that the growth of that particular boy is uniform. It is not happening that left hand is getting elongated by some more dimensions and right hand side is getting less dimensions of its growth, and it is unequal growth for hands and legs. It is always in proportional, always in, you can say, same rate that we are observing. And sometimes unfortunately it doesn't happen. We are calling that human as somewhat, you can say, special person, like that. So this is what I want to convey. So integration means what? Integration of human body means what? Development of body in same rate. You can't separate out any part. You can replace, you can separate, but they are integrated, isn't it? Likewise, now in this all scanner applications, all these components are integrated. Go to next slide. Scanner head, fluorescent lamp, transformer, charge coupled sensors, mirror, lens, filters. These are the components of scanner head. Driving system consisting of stepper motor and belt, control circuitry and interface ports. All these components. That means we can divide the scanner component as a mechatronic system into scanner head, drive system, control circuitry, interface ports. Next slide. Now you will observe that all these components are integrated. All these components are integrated. For the sake of understanding, any issue? Any issue? Any problem with this? Hello? Are you able to hear me?
Yes, sir. Yes, sir.
Yes, sir.
Sound
Yes,
is
sir.
clear.
Continue. Clear. Go on.
So components of scanner which I mentioned in the earlier slide are shown over here with more details. You will observe that all components, all components like carriage, matrix, AC/DC unit, interface module, belt motor, transportation lag, slide rails, everything is shown which is having mechatronics design approach, and they are connected with bus connections. Next slide. Next slide. Now go again on next slide. Go to next slide. Every components is shown over here. Now you just see it is no. Please wait. Please wait. This one components of scanner. Now this is what interface controller. If you observe over here, interface controllers or the you can say various components which are shown over here. It is consisting of ADF adapter, then transparency adapter, then USB, USB transparency adapter. What is ADF adapter? Any of you know about ADF adapter? What is ADF adapter? It is automatic document feeder. It is a feature in printer, photocopiers, fax machines, or scanners where a stack of paper put into machine and is then automatically fed through, though it allowing the user to print, scan a copy without having to manual phase, which is called as automatic uh, document feeder. Then transparency adapter. It is a device or port which is available in flatbed type of scanner to scan 35 of slides and other film transparencies. It provides mechanism that shines light through the film. What is USB scanner? USB scanner is used to connect with the computer or set it up as a wireless scanner on your network. Conserve the space and use a central scanner for all of your business computers by connecting it through USB port, through network router or modem. What is SCSI? SCSI stands for Small Computer System Interface. Here you can interface with this scanner to the computer interface, maybe by USB, maybe by SCSI port, and this is nothing but SCSI port is an American standard, uh, American National Standard Institute (NC) standard electronic interfaces that allows personal computer to communicate with peripheral hardware such as disk drives, then tape drives or CD-ROMs. Next. Now overall working, as I told you, the sensor bar Sensor bar is shown over here. Sensor bar, which consisting of different sensors for scanning the document. Different sensors which is scanning the document. You just see here charge coupled device will convert the light into electrons, and these electrons will be stored in computer as image, and that you are going to store it in the memory of the computer, and this is how the flatbed scanner work. You can understand the application of flatbed scanner as a mechatronics system. Next. Now, as far as this mechatronic systems, as we discussed, we can divide that particular scanner application, divide that particular scanner application into moving parts. Mechanical systems consisting of moving parts, pulleys, gears, and mechanisms. Electronic and electrical systems consisting of microcontroller, analog to digital, digital to analog converter, sensors and actuators. This is the components of electrical and electronic system. Information system consisting of software, and uh, then you are having the user interface that you can uh, having interface with the different ports. This is how the mechanism or scanner components are divided into mechanical systems, electronic and electrical systems, information systems, and user interface. Next. Now mechatronic system example. Let us we will revisit our scanner example. In scanner, what is the input? Hard copy. What is the output? Digital scan copy of that system. This is the example of mechatronic system as we have seen. Next. Now the scanner system is consisting of input as a hardware part and output as a soft copy of the data that you are getting. Now the scanner components are divided into device, systems, scanner head. It is the central part. Scanner is the central part. They are communicated with the different components like drive systems, illumination system, interface device, and character recognition. Character recognition. Now, in scanner part, as we have discussed, this scanner part is the brain of the scanner. Input to the scanner is hard copy, which is to be scanned, and output is soft copy. And parts of this scanner body, scanner head, they are communicated. Right? This is what I want to convey, that all they are integrated. The scanner head is connected with all parts of the system, all parts of the system, that is driving system, which may consisting of pulley and stepper motor. Illumination system will be consisting of uh, you will be consisting of charge, or you can say beam of rays which are coming from CCD, and character recognition which is stored on computer after scanning, and other devices which are used for an interfacing. Maybe you are connecting for printing the document from the printer which is connected with the scanner. That is possible. So all these components are interrelated. That is the beauty of this mechatronics application. If any one of the component get damaged, if possible, replace it. Replacement is the only solution which is available. That too, that we have to understand. Next. Now let us come to the part of electronic components which we have to consider. Electronic and electrical control part consisting of transformer, LED array, CCD scanner, controller, interface device. These are only electronic parts or electrical parts that we have considered here. Now, input is hard copy of document and power supply that you are giving to the electronic and electrical component. As the process starts, scanner will scan the document from the from from CCD sensor and stored into the controller, and then controller will be connected to the or controller will drive the pulse of sequences which will be driving the driving assembly, so that all document from top to bottom and uh, left up to right bottom, all document will be covered, and the beam will be passing on the document in sequential fashion, whatever the pulse sequence of for moving driving for moving drive systems are considered. This is what is the operation of scanning aid, which is nothing but the electronic and electrical part, which is the brain of the computer, or brain of the scanner, what we can say. So always generally brain or CPU is a electronic component that we have to understand. Next. Now drive system, which is mechanical, which generates the motion. Pulse input given from the controller will drive the stepper motor and gearing mechanism, which is connected with the belt drive and which will cause the linear displacement of the scanner to scan the document. Next, engine management system. Those who are from mechanical background, they can able to understand. They can able to understand the engine management system. Now, in this case, 4 cylinders are shown, 4 pistons are shown, and 4 cylinders are shown over here, and position of piston is at different place. This is nothing but the engine management. As we know, it consisting of suction, compression, then expansion and power stroke. These are different strokes of the pistons which are available in engine management system. Of course, ignition is the important part. We can't ignite the engine unless and until it is uh, it is not properly programmed. Now what we can say, I use the word program because right now in mechatronics application, electronic ignition is there, which is in some of the automobile, you can say, companies, they are having smart ignition systems, electronic ignition systems right now, and in majorly in all vehicles, which is integrated into the system and which can be programmed. Engine can be programmed. Driving intelligence can be provided. Gear change can be provided programmatically. Intelligence can be given into the automobile, and that's why this engine management system is one of the important emerging trend which is under development right now in very fast way. In automobile sector, a lot of developments are going on, and definitely there is a lot of scope of development of mechatronics systems into engine management system. Next, now it is shown intake stroke, compression stroke, and intake stroke will cause the you can say camshaft will be moved and inlet valve will open and air fuel mixture will comes into the chamber of the piston, and then outlet valve and inlet valve both valve will be closed, and again compression stroke will start, and high pressure and high pressure and high temperature uh, air fuel mixture will be getting compressed, and it will generate the next step. Next slide. After compression, the ignition will start. Spark ignition, spark for the ignition will be taken place, and the gas inside air fuel mixture will be get ignited, and power stroke will be generated, and machine will cause the motion. This motion will be transmitted to the different wheels to the transmission limb, and vehicle will start. Again, exhaust means after the air fuel mixture burns, then exhaust stroke will take place, and exhaust valve will be open, and all combustible gases will be exhausted into the atmosphere. Now all these things are the steps which are involved in the engine management systems. Now in why we have to understand all these exhaust gas parameter measurement, ignition of the coil, then selection of air fuel ratio, exhaust gas, combustion gas, observation of exhaust gas composition, then speed of operation, level of fluid, air fuel मतलब fuel tank, uh, level of level of fluid in the tank, everything is getting monitored using engine management systems, which is shown in the next slide. Next. Now you will observe whatever we discuss: smart timing, air fuel mixture, fuel injection valve, everything is given as input from the Mac processor. That means you can write down the program, or we can have the algorithms, which is uh, given as input to the engine, and then engine will operate from by it will be observing the speed, then crankshaft position, then spark timing and feedback sensor, engine temperature, throttle position sensor, mass air fuel, everything is monitored, which are the engine parameter and which are sensed by the sensor. If you observe sometimes, if you are going to the, you can say, ऑटोमोबाइल वर्कमैन, ही विल बी टेलिंग दैट सर आपका वो क्रैंकशाफ्ट का सेंसर खराब हुआ है, इट विल बी कॉस्टिंग अबाउट 3,000 4,000 रुपीज, दिस मॉडल ऑफ सेंसर इज रिक्वायर्ड एंड ही इज getting let us say that sensor is of 600 rupees, because of you don't know its operation, you have to pay maybe 2,000 3,000 rupees because you don't know the operation. Common person may not be knowing about the operation of every sensor, but electronics engineer, mechanical engineer, and of course the mechatronics engineer will know the operation of every sensor. If your engine doesn't start and there is no petrol in your, or there is no fuel in the engine, then how it will run? So sensor is there which sends the liquid level in the tank. So liquid level is sensed by the sensor and you are observing it. It may be, now different sensors are available. Crankshaft positions, different crankshaft positions you can observe, which is given as it is a feedback system. Temperature of the sensor, sometimes engine will get heat. You may observe that particular signal. Sometimes if the coolant is not coolant temperature, if the coolant is not at appropriate condition, many times engines are getting heated and it may cause the seizing of engine. If you may face this problem sometimes, it may be happening in two-wheeler or generally this happens in hot temperature, in you can say summer season. Temperature of that particular engine, if it is high because of the operation, then coolant is there. Coolant is trying to cool the engine to reduce the temperature of the engine. And if the coolant conditions are getting worse, then we have to replace the coolant. Otherwise, the proper water should be placed, coolant and water should be placed, so that cooling systems of the engine should be managed properly. This is what is I want to convey, and this is all these things are done in a very smart way in engine management systems. Engine management system is consisting of crankshaft position, spark timing, engine temperature, throttle positions, and mass airflow. Everything is there, which is given as input. So mass airflow ratio we have to maintain, which is smartly maintained by the microprocessor based engine management system. Now we are using it in our daily life, but we don't have angle to see how it works. How it works. So we have to understand that these systems, all these parameters we have to understand. Room illumination. If you observe room illumination on and off, this is simple example. You are keeping on and off of the filament bulb. Next. In more elaborate way, previous one. So we are having power connected, power load and terminal, light bulb. This is the basic system. When you are applying power and when the switch is on, that means when the rocker is placed, then this pivot will connect it to terminal and load, and this bulb will be on. Inert gases which are available in the bulb will illuminate the light. Next. Same thing is shown. In mechanical part, having spring, contacts, switch. Then in electrical part, we are having power source, wires, light bulb, electrical part, filament and chamber, inert gases. Light bulb will be on. Output is the light which is illuminated. This is what is the simple mechatronics system. Next. So, as we discussed, components of mechanical and electrical systems are shown. You just go ahead now. Now we have discussed about this. It is in more elaboration. Go ahead. Next. These are the different examples. Electrical systems, motor, generators, sensors and actuators, solid state devices, signal conditioning circuits, relays, switches, circuit breakers and fuses. All these are the examples of electrical components. Next. Information systems. It consists of communication systems, signal processing, control system, and numerical solvers for optimization. Information systems is nothing but the processing by algorithm. Now don't compare like information systems means information technology or like that. You try to focus on communication systems. Even communication protocols or software, which is a module, is the inherent part of mechatronics. Signal processing. We can apply filters, remove the noise from the signal or image. All these has to be processed programmatically. Control algorithms can be written. Numerical computations can be done for the optimization. All these are the part of information systems. Now, under information systems, you can do modeling, simulation, automatic control, optimization. All these are the content of information system that will vary depending upon the application. Go ahead. Now, what are the different initiatives we are discussing? Hope you are not getting bored, because I am trying to explain the concept in brief, but I want to open the canvas of the importance of these mechatronic systems, because once you open the canvas, once you understand the concept, then definitely you can understand the importance, and definitely I am assuring you, after this lecture or after this session, many of you may be getting more motivated towards mechatronics product design, and some applications will be interested to develop. These are the indicative list of recent trends. You can see that you can't separate out applications from mechatronics. Whatever applications you are telling or whatever applications that are getting developed, all these are under mechatronics. Robotics and automation. Now there is IQ mechatronics concept, which is now attached with the robot. You may have heard this word, you may not heard this word. Robotics and automation. In this, you are having I3 technology in mechatronics. As we have seen, uh, Yasakawa is the company which is pioneer in developing the mechatronics product in all industrial automation side. They are for industrial manufacturers. They are they are having they are the beginners who coined this term as a mechatronics in their company. So they have coined with this new term IQ mechatronics, which is nothing but integration, innovation, and interoperability. It stands for it stands for IQ mechatronics technique. Internet of Things with mechatronics, machine learning applications, automotive engineering application, computer aided and integrated manufacturing application, medical systems, sensing and control system, diagnostics, reliability and control system techniques, engineering design. There are structural dynamic systems, transportation and vehicular systems. And these are some of the indicative list. You can understand the importance of mechatronics. Why this topic is decided by our coordinators, because the importance of this topic. It is integrating. Again, you observe one coordinator is from electronics, other is from mechanical, because they are integrated towards design of this mechatronics. Again, some computer people may also join because they can develop the algorithms. That is the beauty of mechatronics. All this list of indicative list of mechatronics that we should understand the importance by going through this particular topic. I covered topic like scanner. I discussed about scanner. I touched some points of automobile engineering to get the idea to open the canvas of mechatronics applications. Now, go ahead. Next. Next one. That means previous one to this. Previous one to this. You just see this one. Okay, fine. 41 number slide. 41 number slide. This is the brief diagram of block diagram of Yaskawa company, which is Japanese company, which indicates I3 technology, or you can say IQ mechatronics technique, which is used for factory automation and which will affect for different, you can say, see here, IQ mechatronics, here, this IQ mechatronics technique is developed. Next. It stands for, as I told you, intelligent, integration and innovativeness. हाँ सर, मी लेक्चर जरा घेतोय, आमचं लेक्चर चाललंय आता. I am conducting session right now. Yes, yes. Okay. Thank you, sir. Sorry for inconvenience caused. Now, integration, intelligent and innovativeness, which is the advances in mechatronics through big data utilization. Big data means data which is collected and stored on the, or it is cloud computing, what we can say. That is the smartness which is introduced by integrated, intelligent and innovative components over here in this particular mechatronics technique. Next. Now we will touch to the robotics. What is robot? We will go to the case of robot. What is robot? What is robotics? Robotics is the branch of technology that deals with design, construction and operation and application of robot. Robot play a prominent role in every industrial field, including welding, handling, assembly, painting, as well as handling and transfer, etc. It cleans the roofs for rooms for liquid crystal and organic display devices, semiconductor manufacturing, etc. These robots are now playing very important role in all manufacturing sections, for even for PCB manufacturing or motherboard manufacturing, or in healthcare applications, in household applications like maybe painting and welding in industrial grade. Every applications are done by the robot. Hence, the importance of robots that we have to understand in our daily industrial, household, and medical applications, as well as for painting and painting operations like that. Next. Recently, robots have expanded in appeal and presence is not only for industrial but also for other fields by advancing speed, accuracy involvement, response to commands, and strengthening of safety functions toward coexistence with humans. The development of robots actively participating in fields closer to human will continue to advance in future. Next. According to Japanese Japanese Industrial Standards JIS, is it visible?
Yes, sir.
Yes, sir.
Is it no issue of sound? Na?
No problem, sir.
It's good.
Okay, fine. Thank you.
Go ahead, sir.
So,
Go ahead.
okay. So according to Japanese industrial standards, which is called as JIS, industrial robots are defined as machines which have manipulation features or modify the functions that are controlled automatically, able to perform various tasks through a program and are used for industrial purposes. In other words, industrial robots are defined not only by shape but according to their broad functions. This sentence is very important, that in robotic term, robotic is a branch, robot is a device, robot is a model, robot is a product which is developed, and we are not defined based on the shape, how it looks like. It is based on the task that it performs in broad functions. That is what is the robotic importance is. That's why I chose this topic, because basically robotic applications, IoT applications, right now they are at high peak, and as you have seen that right now in COVID situation, everything is getting done without human intervention. That's why for mechanical as well as for electronics people, days in future will be good one, because India has to work on robotics. There is some company called Pari Automation in Pune. They are manufacturing robot. Of course, they have to depend for some components on US and China's. But right now, as far as the Made in India campaigning is concerned, by our government, definitely people get advantage. But we have to keep patience. Like during our presentations also, though it is our day-to-day activity, though we are able to present, though we are PPTs, everything, but we have to keep patience because sometimes technology may not support, sometimes things may not go with our perception. That's why we should have patience. There is a lot of scope for engineering after this COVID situation. So we have to understand that robotics technology will emerge, IoT, robotics, and machine learning technology, which are nothing but incorporated into the industry 4.0. Hence, it is the need of ours that all of we should learn, all of we should understand the basic terminologies of robotic system. Next. Robot components. Now see, an industrial robot consisting of three basic components. First component is manipulator, which moves and perform the. It consists of manipulator, which moves and perform task. Controller will give the actuation signal and controls the manipulator because manipulator will cause the motion, which is getting controlled by the controller, which is generally electronics component. Programming pedant, which teaches the manipulator movement. Yasakawa electric company, which is the originator of mechatronics. I am trying to focus on this Yasakawa electric company because they are the originator of this term, which they are implementing. That's why I am trying to focus on that part. Yasakawa electric company, they have developed different robots, different core components, which are the recent trends. That means in robotics is the recent trends, and again I am focusing on specific company, which is having different branches in India, in other countries of Europe, all over in world. That is originator of that. This is the originator company, which is originally or main company is established in Japan, and they are the leading manufacturer in robot. Next. Now see structure and characteristics of industrial robot. You will observe that as far as our main components of main components of robotic systems that we have considered are concerned, there are three basic components. One is manipulator, second is controller, and last but not least is the manipulator, that is controlling, and programming pedant, where you are doing programs. Controller, programming pedant, and manipulator, which will cause the motion. So here you observe that AC motors are used in. Now you observe there are 6 axes which are shown. Axis S, which rotates body. Ideally it should be 360-degree, but and it is now possible to rotate the axis by 60-degree using AC motor. AC motors are used in for this particular rotation of the body. Then that is called as S axis, which will cause the motion. Then B axis waves the robot wrist upward and downward like our human wrist. T axis, which will rotate the wrist. It is for upward and downward motion. It is for rotary motion. It is again for rotary motion. T axis and R axis. Again U axis, which is shown, moves the axis upward and downward direction, which are the different motions, 6 motions as S axis, B axis, T axis, R axis, G axis, and L axis are shown. and again the directions of that motions are also shown over there. This manipulator will do all these kind of motions, which is as per the programming done is programming pedant, and programming pedant is getting input from the controller. This is what which is shown. This is we have to understand structure and characteristics of robotics, industrial robots. Next. Next. Now we'll go ahead. You skip this part. Skip this part. Next. Fine. Please wait. Before this, yes, yes. Now, next one. Concept of degrees of freedom. Okay. Now, as I told you, there are 7 degrees of freedom for human being. First, moment of the shoulders to swing the arms while walking. Diagram is shown. I will not explain it because by observing diagram, you can able to understand moment of all of the shoulders when spreading the arms. Then 3, 4, 5, 6, 7. If you observe, there are different joints and the angle of motion 3, number 4, number 5, number 6, number 7. All these motions, that means human body is having 7 degrees of motion, 7 degrees of freedom. Degrees of freedom is what? Extent up to what extent you can have choice. That is called as degree of freedom. Now we are living in 3-dimensional era, X, Y, Z axis. So X, Y, Z axis is 3-dimensional and every axis can be rotated in its angular motion. So again, X axis with angular, Y axis with angular and Z axis with angular. It will cause 3 axis for translational and 3 axis for rotational. It will give 6 degrees of freedom. Okay, let us say, for example, I will explain this concept in different way. Go to next slide, as the correlation between that particular degrees of freedom of human being and degrees of freedom of robot is shown over here. Here it is shown that X, Y, Z axis, you just observe the diagram, theta S, theta L, theta U, theta R, theta B, theta L. All these are the angle of rotation, which is shown by the parameter XYZ linear motion and rotary motion. There are 6 degrees of freedom. I can correlate with one example. You just imagine that we are having 7 days in a week. 7 days in a week. Isn't it? And let us say you have 7 goggles with you. We have to choose any one goggle on one day and same goggle should not be repeated. That means, let us say I have 7 days. On first day, I have all choices of goggles. All 7 goggles, you can choose either one of it. That means, in first choice, first day, we are having 7 degrees of freedom. Let us say it is on Monday. On Monday, I have all 7 goggles options available with me, isn't it? So we are on first day when I have to choose first goggle, I have 7 choices. That means I have 7 degrees of freedom. I can choose any goggle. Isn't it? Let us say on Tuesday, now I have only 6 choices. Because first goggle I have chosen on first day. Second day we are having 6 choices. Likewise, on third day we are having 5 choices. On fourth day we are having 3 choices. Like that, number of freedoms to choose the goggles will getting reduced. On last day, on 6th day, we are having only two choices, and that two choices we can take out of the goggle which is available, and on last day there is no choices, only one choice is available which is to be taken. So this is nothing but degrees of freedom. How much extent you are able to give the motion to your robot. So 6 degrees of freedom in artificial intelligence, artificial robot or robotic technology, 6 degrees of freedom that you can find out. We can find out the equations for it. Next, it is shown. All these equations of kinematics are to be considered. Go ahead. Next. Now see, there are different types like Cartesian robots, cylindrical robots. Now mechanical people's faculty may be aware about these types and characteristics. Now Cartesian robots, which is shown over there, Cartesian robots, and what is Cartesian robot? You just see every robot is having different kind of motion. In case of Cartesian robot, it is a simple, and you can say have a simple structure of 2 or 3 sliding axes, where the sliding axes are joined together. They are unable to perform complicated movements. Their precision level is very high. They are easy to control, but you have to use it with the appropriate in the areas of semiconductor, healthcare, or chemicals for tasks such as assembly of small parts or outfitting of electronic circuits where motions are fixed. Next, for the cylindrical robots. For cylindrical robots, we are having the structures that were first used for industrial robot in early years. Their field of operation is broad. They are not suitable for complicated tasks. They require to make all motions or movements. The aim of cylindrical robots rotates vertically and expand and contracts from pivotal axis. The arm of polar robots moves vertically and expands and contracts from pivotal axis. Horizontal motions and vertical motions of the robot. The polar robot is shown over here. Parallel ring robot which is shown over there. So parallel ring robot is like the diagram based on the model or based on the method as per the application. We have to select either one of the configuration of this particular uh, robotic application. Horizontal, next. Now, horizontal articulated and vertical articulated robots. Multiple joints are there. If you observe, there are multiple joints. Joints means where the two components are. Joint means our human body. In our human being, we are having joints, knees. Barabar. This is nothing but the joints. In the robot also, they are called as joints. So, multiple joints of horizontal articulated robots and vertical articulated robots are connected through linkages, each of which makes rotary motions around the joints. The greater the number of joints, the greater the level of freedom, which enables these robots to make complicated movements, including round out moves. Because of this, many robots today are multi-joint The makeup of vertically articulated robots is similar to the human arms, which makes it possible to say that they are probably the most rotational form of robots to use for work to be done in place of humans. Multi-joint robots comprise structures where the joints that are operated by the motor and the links are connected to the in a series circuit. They are sometimes called serial link robots. Since these are structures where the motors are connected in their tips, the closer they are to be root axis, the bigger the motor required, which means that robot will weight more compared to their compared to the strength to carry the weightage, that is load capacity. But they are broader scope of operability and high level of freedom. Now this is what is we have to understand, that weight of the robot or should be proper to move the weight, to carry the weight with them. So there is design to be carried out. Now we will go towards collaborative robot. I am just highlighting some of the points which are required to understand, and this will definitely help you in understanding the concept of robotics operations. Now next is collaborative robot. What is meant by collaborative robot, or which is called as cobot? Cobot means collaborative robot. When you hear the industrial robots, you may associate with some images of welding. That means you are using the robots which are used for welding or painting process, at which are getting automatic now, which is used in many fields including logistics and food other than automobile. Application of robots are now vast. They can be used in logistic operations as well as maybe in automobile operation. In recent years, labor shortage are were more, and that's why the use of these robots increasingly increasing. In addition to, now the same thing I told you, that right now because of this COVID condition, now the way by which we were doing the work previously, maybe the construction work, painting work, maybe fabrication work, maybe labor work where the labors were involved, which may now we are now working on social distancing. So now this social distancing can be done using cobot. So this you have the proper social distancing, and robot will be used for your work, and human and a robot will be working collaboratively, which is called as collaborative robot, or you can say cobot. There is a big hurdle for small and medium-sized companies and to install the robots, because working areas for the robots by safety fence, which required sufficient space and installation cost. The ordinance about this, to use this cobot, the ordinance of industrial safety and health was revised in 2013, which enabling us to install robots without safety, to secure safety for human, and thanks to advancement of robot technology for enabling such kind of safely sensor with collaborative robot which can work with humans in limited space. Now many manufacturers are providing collaborative robots. It is not just like the advancement of robot itself. There are many products which are invented for those who are familiar with the operation, to teach robot movements with the programming pedant that functions with tablets, and every part. Programming can be done using tablets also. So this is what is nothing but the collaborative robot. Next, these are some of the applications of collaborative robot which is used in previous one. previous one. Uh, within an inter-equipment terminus, various parts arranging box packaging. These cobot robots are shown. Next. Next, quality inspection and measurement, PCB manufacturing, it can be done. This is what is the Yasakawa electric collaborative robot, which is now called as Moton SC series, which is Moton SC series is able to work with the same space as human with with the robot as human, incorporating a structure that reduces the risk of fingers and hands being caught and safety functions that minimizes damage by contacting with humans. It also direct to teach button that makes operation easy for those who are not familiar with operating robots. In addition, it also offers hand carry type of mounted on a movable cart and can easily be moved as needed when the changes in production plan and line layout occurs. Motocon SC series, which 10 SC series will expand with new manufacturing. Motoman SC10DT is a cobot available with Yasaka Electric Company. I am requesting all of you to please visit Yasaka Electric website, which will be giving you the information about this particular cobot and new trends over here. Next. Next. Now IoT and mechatronics. IoT and mechatronics, these are evolving state and the concept of Internet of Things, which is all about the interconnection of machines and device to network through sensors, network communication protocols, analytics, and specific software towards uh, is trying to work. It was with mechatronics. This is relatively new concept, though the engineering in mechatronics existed for more than half century. But IoT with mechatronics is very new concept in that regard. Next. 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 Next slide. Mechatronics and embedded product design with IoT product design is having embedded system design, PCBs, previous one. Key concepts of IoT. First of all, we have to define the definitions of IoT. As it is shown, embedded product design, PCB design and development, mechatronics, product design, IoT product design with mobile app-driven products, security, every part is there as a list of applications. Key elements of key concepts of IoT, definitions, enabling technologies, connectivity module, transformational potentials, security, privacy, interoperability, or standards, legal, regulatory and rights, emerging economy and development issues. These are the key issues that we have to understand. Next part. Communication technologies of IoT are nothing but the wireless fidelity, wireless sensor network and artificial intelligence. Next part. IoT is based on this Wi-Fi, WSN, and uh, artificial neural network. Now, what are the definitions of IoT and key layers of IoT? Now, just see, IoT is the term which is called as Internet of Things. Generally refers to the scenario where network connectivity and computing capability extends to the objects, sensors, and everyday atoms not normally considered computers, allowing these devices to generate and extend the consumable to consume data with minimal human intervention. There is, however, no single definition which is universally accepted for IoT. Now, these are the key layers. As I told you, these are the key layers which are shown over here. Application layer shown in the figure. Application layer consisting of the applications and services provided by IoT are included in this layer. Applications include smart cities, smartphone, smart home, transportation, utilities, healthcare services, which includes IoT based, which it also includes IoT based car rental, social assistive robots, SARs, and robot security guards. Perception layer, which is shown over here. Perception layer is nothing but different kinds of sensors which are connected in this layer. Sensors are used for sensing the room temperature, moisture sensor for IoT in agriculture, RFID sensors for retail storage and transportations are the examples of perception based sensor. Perception based sensor is nothing but the node where attacks can be done, or it may be information can be stolen as sensors are connected directly with the perception layer. Network layer is the main purpose of the network layer is to maintain the communication to and from with different devices. Network software and physical devices such as topologies, routers, switches, and servers work in this layer. Physical layer is the physical objects such as smartphone, again, robots, smart appliances work in this layer. What is the hurdle of this? Hurdle of this is nothing but attacks which are there in mechatronics system at different IoT level. With high adoption rate of IoT in mechatronics system, more and more devices are connected to internet. As IoT is the connecting more and more devices to the home of the office networks, attackers are targeting these devices for stealing the various important information. The following section, this particular, you can say, importance is nothing but the attack. Attack on application layer can cause system not to run properly and enable to verify the and, and unable to verify authenticate request or user. Attackers are inserting how they are attacking. Attackers are inserting some malicious code or program to the system that causes the system to malfunction. With popularity of IoT, more devices are connected in cyber space and number of applications uses are increasing well. This making the application layer more vulnerable as number of targets, cyber targets are achieved. SQL injection, which is SQLI, different types of attackers are they're applying their programs, some instructions, some programs, some code on the perception layer. This is where the weak line of the IoT is there. Next. Now device to device attack. As DOS stands for Denial of Service attacks. These denial of service attacks attack is the attempt to make computer or network resources unavailable for its intended user by interrupting or suspending the services running with the system or communication network. Denial service attacks, DOS attack, can make the central processing unit, memory and communication module slow or unusable or impossible to use. The main purpose of this DOS is to hamper the availability of the system. This can make the authorized users enable to use or log in to the system. This particular figure which is shown or demonstrate the basic DOS attack. Master machine is the target and slave machines are the infected or malicious devices making DOS attack to the master device. DOS attack is an attempt to make the computer or network resources unavailable for its intended user by interrupting or suspending their services. Next. And now see, go to previous slide. It is shown device to device attack. Device to device means what? Device to device. Wireless network. Device to device means wireless network. Bluetooth or you can say Z-Wave or Zigbee. They are connecting manufacturer A light bulb of manufacturer A and light switch of manufacturer B. This is what is device independent. Only single device can be connected to this particular IoT technique. Next, device to cloud communication. Now you will observe that application or service layers are coming into the picture. It is a device to cloud communication model. The IoT device connects directly to the internet cloud and internet cloud service like application service provider to exchange data and control the messages and traffic. This approach frequently takes advantage of existing communication mechanisms like traditional wired, Ethernet or Wi-Fi connectors to establish a connection between device and IP network, which ultimately connects to the cloud as shown at this particular diagram. Next. Then example of gateway model or example of device to gateway communication model. Here what we can say is that the device to gateway model or more typically device to application layer gateway model. The IoT device connects to application layer gateway services to conduct or to reach a cloud service. In simpler terms, there is application software operating as a logical gateway device, which acts as intermittently communication device between device and the cloud service and provides security and other functionality such as data or protocol translation. This model is shown in the next. Backend data sharing model. Backend data sharing model refers to the communication architecture that enables the user to export and analyze smart object data from cloud service. The architecture supports the user desire for granting access to the uploaded sensor data to the third party. This approach is an extensive of single device to cloud communication model which can lead to data where IoT devices uploaded the data or a single application service provider. Backend sharing architecture allows the data collected from single IoT device to, to be aggregated and analyzed. Next.
Sir, sorry to interrupt you. So how much it will take? So we have to extend the timing of this meet.
Uh, for next 15 minutes.
15 minutes. Okay, so I
15
will.
to 20 minutes. 20 minutes.
Okay, I will tell
Not
organizer
more.
to extend time. Okay, okay, okay. Thank you, sir.
Is
Because
it fine
it's
or
4. Yes, yes.
is it fine or getting bored?
So I have to ask participants.
It's not about getting bored, sir, but about time frame, because there will be question answer rounds we should expect.
Okay. So I will complete the things fastly afterwards. Okay. It
Yes.
will not take much more time. I understand. Yes, sir. Uh, these are different models, or you can say IoT-based products or devices which are shown. Enclosure designs for asthma inhalers, then smart, you can say smart block hardware design and IoT applications like that. Next. This is smart city and IoT applications. Data collections from various sensors from the environment, or let us say traffics, all information detection of traffic jams are collected by the sensors. That means all sensors are collecting information and it is giving to the cloud, which is collecting the information of traffic management system, and sensors are connecting carbon monoxide, nitrogen oxide sensors. Uh, they are collecting and different nodes are shown. These nodes are nothing but the perception layers where sensors are connected, and then they are, you can say, uh, feeding the information to the cloud. Cloud is collecting information uh, from all wireless sensor network. They are connecting the information and finding out that where the pollution is high. Even they can be used for traffic management platform. A decision is taken by the smart systems. Next. Now I am putting some questions basically here, that does mechatronics have scope in future? Mechatronics is a combination of various fields of engineering. It is having large scope in future, and it is having large area of application. So there is no question that whether the mechatronics is having the scope or not, having good scope in future. Next. Next. Is mechatronics is major? Yes, it is a major branch, as it covers robotics and automation engineering and all disciplines, building on solid base, maths, physics, chemistry, electronics. You will focus on programming and control, physics of mechanics and automated systems. You can undertake special design project under this. Next. Next. Which countries are best for mechatronics? Uh, South Korea and Germany, Singapore and Japan. They are basically originated in Japan, but after that, South Korea, Germany, Singapore, they took lead over there. Next, machine learning in mechatronics. Next, uh, obvious question that arises in researchers' mind is machine learning and mechatronics are related. What is the difference between machine learning and mechatronics? How is the machine learning is used in mechatronics? Which machine learning techniques are used by the robots? Next. Yes. Need of mechatronics and machine learning related. They are related, yes. What is difference between machine learning and mechatronics? Machine learning is about the moving mechanical devices, and machine learning is the method of training a neural network on what output should be given under a certain condition. Eventually, a robot can be moved as a result of machine learning process. We have to provide intelligence. Next. Next. Which machine learning techniques are used in robots? Computer vision, imitation learning, self-supervised learning, assistive and medical technologies, and multi-agent learning. Next. 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 I will go fast because case study. Uh, I think uh, one of my friend who is working on uh, this particular topic. Professor Vibhute is there. Professor Vibhute. Professor Vibhuti is there on the participant side.
Yes, sir. I am there, sir.
Uh,
I am there, sir.
so, okay. So let us discuss about the setup or the experimentation that you are doing within 5 minutes, 5 to 7 minutes.
Yes, sir.
What exactly you are doing and how it works as a machine learning application
So,
for robotics.
basically, my aim is to detect sound source or localized sensors in 3D space around the head of a robot. But by using only 2 microphones. Many researchers have used more than 2 microphones, but I want to imitate as a human hearing or binaural hearing is called. So for that, I am the robot or the hearing senses of the robot to understand the localization of a sound source. So can you move to the next slide, sir? So in brief, uh, first I have done training of the robot of its sound hearing capacity. I have divided the head of the robot into 8 octanes, a standard 8 octane which you do in maths, and then each octane. Can you go ahead? And for training purpose, I have placed a known sound source in these 8 octanes and I have recorded the level of signals. And on time of difference of these signals, I have identified it is located in which octane. And then octanes. So move ahead, sir. Can we move ahead in the slides? Yeah. And out of those 8,000 recordings which I have done, I have used 75% for training purpose and 25% for the validation purpose. So in training purpose, from the 75%, this is the hardware which I have I'm using. 75% I'm getting very good accuracy of localization in the 8 octanes, and in validation I'm getting up till 94% accuracy of the sound localization. And when I have done on real trials of unknown, I'm getting up to 90%. So by training the robot about what he has to do, or which is called as supervised training, it is possible to implement machine learning in mechatronics. So can you move on to the next slide? So this is by proper and supervised training, and then I have used binary classifiers or multi state classifiers. Like LD has given me a good result than other classifiers. So training the classifier is very important for a machine learning process. And if you can make a proper data set and labeling them properly, having proper training, then surely machine learning will be very helpful in mechatronics. Thank you, sir. Over to you, Angal, sir.
Hello.
Over to you, Angal, sir.
Okay, fine. So he has explained very fastly, as I think time is extended, getting more and more. So just I want to highlight that machine learning is one of the good technique to be incorporated to provide the intelligence in the system, and the results which are shown. Go to next slide. Hello. Next slide. Next slide. Next slide. So this is how they want to find out the sound localization using machine learning technique. Thus, 8 sounds are placed at different locations at equal distance. For an example, for simulation that we have done, and there are, let us say, there are 8 sources. The machine learning algorithms, LDA based algorithms, and different algorithms that are used for this, they are uh, they are getting verified to find out the sound location of this particular, you can say, application. Next, data sets which are used for recording are 8,000 samples. Number of recording per, you can say, 8, you can say, sources. There are 100 recording per source. Out of that, 6,000 data, 70% of data is used for training data set, and 2,000 which are exclusively different are used for testing data set. Next, next, next. Next, these are the results of using linear regression technique 59.1%, LDA technique 93.4%, maximum likelihood estimation 90.4%, k-nearest algorithm 88.7%, and support vector machines, it gives result of 69.4%. So as per the experimentation done by Professor Vibhute, results of LDA method are up to 93.4%, and fast acceptance is almost 5 to 10% as per the results application. Next slide. There are various applications in disaster recovery, locating people, then unmanned ground vehicles, human machine interface, aid for physical handicap person, locating person in cloud. Next. These are some references which are used for this presentation. Just for the reference, just go ahead. Next. Next. These are some references. I am very much thankful to Dr. H.D. Markande sir for giving me opportunity to deliver my session in this particular FDP. I am thankful to Dr. Makran Jadhav, HOD ENTC of NBL School of Engineering and Engineering, Pune, and Dr. B.H. Burande, HOD Mechanical, for their for giving me opportunity and express my view. Basically, due to this, you can say, connectivity issue, the synchronization.
Yes, thank you. Thank you, sir.
Joshi sir.
Angal sir, thank you very much
I,
for your presentation.
yes.
To participants might have enjoyed your sessions.
Yes, I'm very much
Yes, thank
thankful
you
to
for this wonderful session.
Dr. Vivek Angal sir for nicely delivering this particular session on recent trends in mechatronics. We were all benefited by these various concepts in mechatronics, which you elaborated through your nicely prepared slides. I thank you all the participants also for hearing patiently throughout the session. Neeraj Patil sir, Simon Jadhav sir will make some announcement for tomorrow's session also. If there are any questions and all that, Neeraj Patil sir will handle please. Thank you very much.
So for one instruction for the participant is that tomorrow the afternoon session will be conducted at 9 a.m. So after that session, afternoon session will be conducted at 9 to 11 a.m. and after that morning session will be continued. Okay, so tomorrow at 2 to 4 there will not be any session. That session will be conducted 9 to 11 a.m. Okay, so that is the one important instruction for all participants. And the link for the same.
Hello.
Yes.
There is no question from participants.
Yes. If any participant has a question, he can raise hand, and you can ask by unmuting yourself. Any questions?
Hello, sir.
Yes.
Hello.
Hello.
Speak.
Hello, sir. Yeah.
Yes, you are audible.
Yeah. So hello, so what is the scope of graduation in mechatronics nowadays for the students, B students?
What is scope of mechatronics in?
Mechatronics, graduation in mechatronics, B in mechatronics. What is the scope for the present scenario for the students now?
Basically, in all robotics industries, in South India, as well as because major focus of these particular robotic applications are there in Chennai, Bangalore, over there. So mechatronics engineer can do work in robotics application.
Yes, sir.
And as well as for all IoT based projects, mechatronics engineer can work. Yasakawa company is having one branch in India, and likewise there are a lot of industries. Basically, required mechatronics engineer. Such kind of advertisement are not available in any of the government sectors or in private sectors. Isn't it? Right now, it is emerging a part, and students are they have to understand the fundamental things when they are applying. But mechatronics is there for both mechanical in CNC industries. They have to basically government has to think of for this right now to create specific jobs for mechatronics as such. Otherwise, mechatronics engineers work is done by electronics people separately and mechanical separately. But industry point of view, there is a lot of scope for development in India.
Thank you, sir.
Any question? Any other? Generally, in robotics and all area, wherever industries are there, mechatronics people can, but industries are not writing directly wanted mechatronics engineers. That we have to change it. That means this will be happening. It is applicable for our process industry, automation industry, everywhere.
Thank you, sir. Thank you, sir.
Sir, 3D printing will be useful in mechatronics.
Which?
3D printers nowadays they are available.
Which tools are available?
In mechatronics. Yes.
Which tools? Which tools are available?
3D printers. 3D printers.
Yeah.
Nowadays they are available. They are useful in mechatronics.
Yeah. 3D printer is also a good example of mechatronics. Basically, we have to orient ourselves towards that. How they relate with the mechatronics. Isn't it?
Okay.
Laptop, camera, mobile, everything is an example of mechatronics from electronics point of view, IoT based applications. in mechanical CNC machines?
How to start with mechatronics? Simple things
Small
which we
projects.
can do.
Yeah, you
A
can
small
ask your
project.
you can ask your students to develop a small projects of pick and place robot in their graduation sessions. Then IoT based healthcare unit. That small projects with 1 2 parameters are acceptable because mechatronics persons have to work on hardware as well as on software. They have to work on
As well
software.
as
Yeah, and with sensor interface. So it is a very good branch and a very good scope in future in foreign countries like Japan, Singapore, South Korea. They are having mechatronics as a one of the top branch, isn't it? And now again, many universities are trying. And in South India, I think uh, there are specific branch like Anna University having specific mechatronics branch.
yeah. It means the mechanical and electronics branch has to be there. Then only you can start with mechatronics. Otherwise,
Not like that. Mechatronics special course is to be
ah,
designed. In Pune University, we are trying for it right now. Separate course of mechatronics. That means this syllabus will contains all that part which is required for mechatronics engineer. They may not go to separate mechanical and separate electronics person. Mechatronics person can do
Sir,
both the syllabus will be designed.
Angle sir, we
Ah,
have MTech in mechatronics. There is one
we have
special postgraduate in mechatronics,
yeah
and
in
we have
Siankad
it.
Institute.
Hmm.
Yeah.
Yeah,
In Siankad Institute, they are having ME
yeah,
Mechatronics as a special branch.
huh.
In
Yeah. For 2
mechanical,
years,
yeah,
mechatronics is
2
there.
years, yes. So syllabus to be designed like that, so that mechanical electronics persons can be replaced. Instead of two, they can work with one. Instead of four, they can work with one engineer. Because the person will be knowing about programming aspect, mechanical design as well as electronic design part. Syllabus is designed accordingly.
pure
Any question?
disciplines they are going to vanish.
Huh?
Pure disciplines will vanish.
Yeah. I am not able to hear your sound. Any more question? Any question more?
Ah,
No
sir.
questions.
Nowadays the pure
No
disciplines will
question.
vanish.
I am not able to hear sound of anyone.
Hello?
We should stop the session. If anybody has that questions, we can pass on that through mail to sir also afterwards.
Okay, fine. So
Ah,
can we
happy.
conclude the meeting now?
Yes, sir, please.
Yes.
So I am thankful to Makarand Yadav sir. Special thanks to you for giving this
Yes,
opportunity and your management and principal. Thank you very much.
yes,
Thank you again. Bye.
yes. Thank you, sir. If there are any questions are there, we'll mail you, sir.
Yes, if there is question, then I can answer. Otherwise, we can conclude.
No, I will mail you. If there are any questions are there, we'll mail you, sir, afterwards. You can answer these questions to them directly. No problem.
Okay, fine.
Yeah. Thank you, sir. Thank you.
Thank you.
Thank you, sir.
So close. Should we close the meeting, sir? Jadhav sir?
Yes, please. You can close the meeting. We can resume tomorrow at 9 o'clock.
Definitely. Okay, sir. 9 o'clock.
Yeah, thank you. Yeah, 9 o'clock. So 8:45.
Yeah.
10 minutes.
Sure. Okay,
Yes.
sir.
Thank you very much, all of you.